All right, guys, this is a review for our Unit 3 test. All right, so the first question is asking you to rewrite each expression in radical form. So remember, radical is your root, okay? So we are going to make a root 2. The big 2 goes on the inside. Now the bottom 3 goes on the outside, and the other 2 goes as a square, okay? Now for B, first, we're going to make a root. Y, which is on the inside, goes on the inside. A, which is the bottom, goes on the outside, and 4 goes here. Now, what we cannot forget is this negative. And remember, what does a negative mean? It goes to the bottom of the fraction, so we don't have anything else to put on the top. So we're going to put 1 over. This negative indicates it goes to the bottom of the fraction, okay? Now, for number 2, it's the opposite. It's telling you to put it in that exponential function. So again, we're going to do the 8, which is on the inside of the radical. We're going to make a fraction. 3 on the outside goes to the bottom. 2 on the top goes to the top. Okay. Here we have an x. X doesn't have a number. That indicates it's a 1. So again, x, a fraction. What goes on the bottom? The 5. And then the invisible 1 goes there. All right. Simplify each expression using the rules. So question 3, remember that 1/3 is on the outside. So that means that 64 and x are not together, they separate. So 64 gets an x and it gets a 1/3 and the x gets a 1/3, okay? So we're going to separate and write 64 now raised to 1/3, not multiply 1/3, raised to 1/3. So it's to a power of 1/3, okay? And then we're going to get x 15 repeated to 1/3, okay? So here 1/3 it's going to be put into the radical. So we're going to use decimals. We're going to say 64 raised to 1 over 3. Okay, so we get a 4. So this, now it's a 4. And then here, 15 raised to 1/3, we multiply them out. So we're going to multiply 15 times 1/3. So again, it's not 15 raised. Okay. This is not 15 raised to 1/3. Not like that. That's not it. Okay? It's 15 times 1/3. Okay? Times 1 divided by 3. Okay? So that's 5. All right? So once again, this is to a 5th power, and that's your final answer. Okay? Now here, we got a 2 on the outside. So again, this is a fraction. So 2 belongs to the top and the bottom. So we're going to rewrite it. The 10 gets a 2, not 10 times 2, 10 raised to a 2nd power. And then 10 to a 2/3, it's now raised to a 2nd power. Now, a lot of you guys that I noticed during practice were trying to take 10 squared, leave it as it is. First, multiply the bottoms. So 10 squared. Here, 2/3 times 2, that's 10 to a 4/3. Okay? Now again, what we're going to do with the exponents now, since it's in the fraction, we are going to subtract it. So it's 10, 2 minus 4/3. And again, I prefer if you guys use calculator. So we're going to get 2 minus 4 divided by 3. And again, remember that right here, you can turn it into a fraction, 2 over 3. So that means this 10 is raised to 2 over 3, and you can leave it that way. Okay? Now, write it down. I'm going to clear the page. All right, next one. Again, we always do things next to each other first, and then when we have one thing on the top, one thing on the bottom, then we subtract. So these two, we are going to use the property when we add them. So that's 3 plus 1/2. So once again, three plus 1/2, it's 3.5. That's 7 over 2. So on the top, I get 7 over 2, and on the bottom, I get 5 over 2. Now when I have proportionally 1x on the top, 1x on the bottom, I'm going to subtract their tops. So 7 over 2 minus 5 over 2. You're going to get 2 over 2, which is 1. So the answer is simply x, because we do not write the power of 1. All right, next one is just 1a and 1a. So we are going to use the subtraction property because this is a fraction. So again, that's a 1/2. Now the trick here is you're subtracting the negative. So you got double negative because you're subtracting the -3. Once again, we're going to do 1/2 minus -3. So we get 3/5, which is 7/2. Okay. Next one, again, you're subtracting. So that's 3/11 minus 8/11. You are going to -5, get -5/11. Now, that means you get c to a -5/11. So that means that this negative, let me remind you what this negative means. Negative means bottom of the fraction. So that's c to a 5/11, and the 1 goes on the top, okay? Now again, pause that if you need to. All right, now the last one I got to convert. So that means I got to change it to a fraction. So c to an exponential function. So c and then the fraction, 4 on the bottom, that's on the outside, 7 on the top. Now here I have 3 3/4, so I got to multiply and use a multiplication property. So 3 times 3/4, it's 9/4, okay? And now since it's 1c on the top, 1c on the bottom, we are going to subtract. So again, 7/4 minus 9/4. And you guys are going to get a negative answer. And the negative answer is 2/4, which is 1/2. So let me just make sure everybody understands. 7/4 minus 9/4 is going to be -1/2. Okay, that's how it simplifies. So -1/2, remember that a negative exponent leads 1/1/2, like this. Okay. All right. Now moving forward, this one, number 9, you're only doing the a's together, things that are alike, and of course you're going to add them. So once again, we adding 4/5. Okay, 4/5 plus -1/5. And we are going to get 3/5. So A, it's now to a 3/5, and then B just stays by itself. I can't do anything about the B, so we're just going to keep it in this form. We cannot add them, nothing. All right. Now here I'm going to convert it for question 10. I'm going to change this. Remember that there is a 2 there, not a 1. So we are going to change this to B 10/2 and a B 12/2. Of course, now we have a B on the top, B on the bottom, so we can subtract the top minus the bottom. Okay. Sorry about that. All right, so that's going to be -2/2, which is really -1. So what does that mean? B to -1. How do we write it? Remember, it's 1/B. So it's going to be answer A, not answer C. Answer A, because it's B to a first power, okay? Again, pause it if you need to write it down. Now, lastly, here, you also have a 2 and a 2, but remember that now it's not a fraction. It's on one line, so you're adding it. So we're going to convert it to make it 11/2 times B to 6/2. And again, you're adding their exponents. So 11 plus 6, it's 17/2. So it's going to be a B to a 17/2, which is an answer C. All right, and then lastly right here, I have to convert it. So here it's asking me what is the exponent I'm raising the x to, okay? So first I have to convert the x and put it in a fraction. So this is a 9 that goes on the top and 5 on the bottom, because 5 on the outside. On the bottom here, I have a 3 4/5, so I'm going to multiply it. So 3 times 4/5 is going to be 12 over 5. Now I have 1x on the top, 1x on the bottom, so I can subtract it. So again, that's 9 over 5 minus 12 over 5. So that is going to be negative 3 over 5. Now remember, that's your x. Negative 3 over 5, that is your answer. So what is your y? What is this? It's negative 3 over 5, okay? Now how would I write it all together? I would write, so this is my y. So I would write x to a negative 3 over 5, which then will end up being x to 3 over 5 over 1. But that's a formal answer. What is the question asking you? It's only asking you what needs to be. What does x raised to? It's raised to negative 3 over 5. So your answer is negative 3 over 5. All right, now we're going into graphing, okay? So first it's saying identify the transformations for this function, okay? So without looking, I can tell that plus 3 on the outside means I am going up 3 units, okay? I don't have anything underneath the radical with x, so I'm not moving left or right, but I do have a negative in the front, so that's a reflection over x-axis. And I also have a 2, which indicates a stretch by 2. Vertical stretch by 2. Okay, because remember that 2 is bigger than 1, and that's a stretch, not a shrink. Okay, now, if I graph this, which again, you put it into a graph. Very important, remember f of x equals negative 2. Now remember that the radical, there's only x underneath. You got to move that arrow to now add 3. Okay, so this is your point where it starts, 0 and 3. So if I graph this here, the point is going to be right here. This is 3 and this is 0. So it's going to go something like that, okay? So it's asking you for domain and range. So remember, domain is x-axis. So this point, 0, because this is 0, 3. Point 0 represent domain. Now, where is it going? It's going from 0 to the right, so infinity. So 0 to infinity, it's one way to write it. And of course, we need close parentheses and the number 0. We can also write all the x's that are greater or equal to 0 because we're going to the right, okay? Now range, you would want to see 3. 3, it's the number for the range because that's a y and range represents a y. And you would want to really, what you want to say is 3 to infinity going this way, negative infinity, right? But remember, we don't read the graph that way. How do we read the graph? We read it from a left to right and bottom up. So we are going to say negative infinity to 3 this way, okay? Now, if you want to do it the other way, you would say y, it's less or equal to 3. This is what you would say. So that means you're going down from 3, okay? So it would be this way, below 3, okay? All right, now write it down if you need to pause it. All right, now question 14 talks about false statement. So false statement means not true, okay? So it's asking you for transformation, all right? So what can we say right here? I have a 5 in the front, so that's a stretch. I got a negative 6 on the outside, so that's down 6. And I have a negative 1 on the inside, which is the opposite, so that's right 1. So let's see, vertical stretch by a factor of 5, it's correct. 6 units down, it's correct. 1 unit to the right is correct. 1 unit left is not, okay? So that would be your answer. All right, now question 15. Oops. Question 15, again, talks about writing what the function will be after transformation. So remember that this is a quadratic, this is a radical square root function. So we're going to start with the x. That's what it starts with. I made a space. Now, here it says that I am vertically stretched by a factor of 5. So again, stretch, shrink always comes on the outside. Translated 2 units up, so it's just +2. There is no left or right, so I did not really have to make it that big because we don't have any movement left or right. Okay, it's just going to be 5 on the outside because that's a stretch of x, and then 2 units up on the outside. Okay, f of x. All right, 16, again, square root of x. Okay, now it says reflected over the x-axis, so reflection is a negative. All right, it says vertically compressed, so that's shrinked of a factor of 1/2. Again, shrink and stretch doesn't matter, it goes in the front. Then translated 4 units to the right, so that's on the inside. We're going to go -4, the opposite. And then 1 unit up, so that's an outside 1. So again, that's your function. Don't forget the negative for reflection. 1/2 goes in the front, 1 up, and 4 units. All right. Now for these right here, we can very quickly put them into decimals. I'm going to go one by one. So question 17 is, and again, how do we put it? We split them in half. We're going to say 2x plus 23. And on the other line, we're going to put square root of -1 minus x, okay? All right. Now we're going to look, make sure that we are looking that they only cross each other at 1, and that is at -8, your x value, okay? So here, the solution is x equals -8, okay? Then we're going to do number 18, the same thing. All right, we're going to put x minus 2 on one line, and we're going to put square root of 3x minus 8 on the other line. And once again, we're going to press home, and we're going to look for it. Now, this one crosses twice. I want to recognize that both answers are correct. Okay, you can have 2 answers or 1 answer or no answer. So 4 and 3 are both your solutions. So 3 and 4 are both solutions that work, okay? Question 19. We are going to have an x on one line, and we're going to have a 1 plus square root of 2x minus 1 on this line. And we're going to look, and it's going to be a decimal. That's okay. Okay, it doesn't give you a whole number. It's still a decimal. You still have a solution, 3.41. Okay, so x will equal 3.41. It's just not a pretty one, okay? All right, question 20. All right, for question 20, very important to make sure that you see that it's just square root of x. Okay, x minus square root of x, and then you're going to put 2. 2 will not work by itself. You have to put y equals 2. Do not put x equals 2. It's going to give you the wrong answer. Y equals 2. You need a y value to cross. So this, again, you want to zoom it out, make sure it doesn't cross anywhere else. It's only crossing at 4. Okay. All right, question 21. We are going to plug it in. It's going to be 3x minus 1, and then plus 9. And on the other line, again, not x equals, y equals 8. Okay, and again, as you notice, these do not cross each other. What does that mean when it does not cross each other? That means no solution. This one has no solution. Function do not cross each other, okay? All right, now, this is question 22. This is asking you for extraneous solutions. That means the ones you do not see. Now, how would you get them? Well, one, by hand, you will square both sides to get rid of the radical, okay? So you will get 50x plus x equals x squared. Now you will combine like terms, meaning you would move 56 and x to the other side. So minus 56, and minus x, and minus x. And you will combine like terms. You will get a 0 here, x squared minus x minus 56. Now you would find 2 factors and multiply 1 times the last one. So you would get negative 56, and you would get a negative 1 here. because again, that's -1. And the two factors that you would get would be, I believe so, 8 and 9, I believe so. 8 times 9. Nope. 8. 7 times 8. Yes, 7 and 8. Okay. So we will get 7 and 8. 7 times 8. And of course, to get -1, 7 has to be negative. So we would get x minus 7 and x plus 8. We will equal them to 0. So x minus 7 will equal 0 and x plus 8 will equal 0. And we would solve it. Okay. So we would get x equals 7 and x equals -8. Now, to check if they both work, we'll go ahead and graph it, because we need to see which one does not work. Okay. Now, if we graph it, we get square root of 56 plus x. Okay. And then here we will get x. Okay. And then here we get 8. So out of these two solutions, only 8. Nope. Oh, I made a mistake. Look at that. There should be positive. There should be negative, because the bigger number got to be negative. So this needs to be negative. This needs to be positive. So that's negative. That's positive. So I made a mistake. So x equals -7 and 8. Okay. Now it's saying 8 is the only solution. So -7 will not work. How can I check that -7 does not work? I can plug it back in. Square root of 56 plus -7 equals -7. So 56 plus -7 is 49 equals -7. 7 does not equal -7. Okay, that's why it does not work. Now, what is my extraneous solution for this answer, for this question? Extraneous is x equals -7. That is my answer. Okay, 8 is a solution. Now, can you use Desmos to check which one will work? Yes. You can plug this in like this, or you can just plug it in like this. Okay. And then on the second line, what you can do is basically on one line, you're going to plug it in the actual answer. Okay. So the actual question, 56 plus x equals x. That's on the first line. On the second line, you are going to plug in the next step after you would square it, which means 56 plus x equals x squared. Okay, so if I do that, if I do without the radical, and I'll make sure that I remember to x squared the x, now you get both. And I want you to see what happens. If I don't plug it in, I only get 8. That's my answer, right? That's my solution. That's what the answer for this question is. Now, extraneous is the other one I cannot see. So if I plug this one in, now I see both of them. So you went in right here and you squared it and you plugged in when you got rid of the radical, and this one, it's now squared. So the same insides here. Now you can see both of them. This is the solution. This is what you need, which is extraneous. That is what I'm looking for, okay? All right. So that just checks my answer, okay? Now, let me erase that. Now, can I do the same thing for this one, just using Desmos? Absolutely. So that's 12. So I'm going to plug in that 12 plus x equals x. And then on the second line, I'm going to square it. I'm going to plug in 12 plus x equals x squared. And I'm going to see which one it's not the one that works. So here, it's going to be 12 plus x equals x. And then here, it's going to be 12 plus x equals x squared, because I got rid of that radical. So now again, as you see, blue one, correct answer is 4, okay? And then here, the other answer, because the 4 covers, is -3. So x equals -3 is your extraneous solution. Okay. Now we can also go ahead and try to solve it. Okay. All right. Now this question right here, domain and range, again, I would suggest that you guys graph it. So this is f of x equals negative, then square root x minus 1 plus 4. Oops. See, don't make a mistake like me. Make sure that the 4's on the outside. All right, so now if I go home right here, what are my numbers? It's 1 and 4. So I'm going to go back here, and it's 1 and 4. So somewhere right here, and it's going to look something like that, okay? So this is 1 and 4. All right, so domain will have something to do with 1, and range has something to do with 4. So once again, domain is from 1 to the right, so 1 to infinity. And you can also say all the x's that are more equal to 1. And domain is going down to negative infinity from 4, so this way. But we're going to say negative infinity to 4 because we're reading it the opposite direction. So remember that we're reading it from negative infinity to 4, and it stops at 4. So that's your range. Now you can also say all the y's that are less or equal to 4 because all the numbers are less than 4, okay? Now, positive and negative, I will definitely graph it because my graph is not accurate. So remember the positive and negative numbers are numbers that are going to cross somewhere here, right here at 17. Okay, so that's the number right here that determines. Now, I want you to see that positive numbers, okay, let's do purple. Positive numbers are the ones that are above x-axis. Okay, this is your x-axis. Now, all the numbers that are below x-axis are going to be negative. So this is all negative. So how are we going to write that? We're going to write it from this point. This point was 1, 4. So from 1 all the way to 17, all the numbers are positive. So 1 to 17, they're positive. After they hit 17, all the way to forever, they are negative. So negatives are going to be 17 to infinity because you're reading it left to right. Okay? So, again, from 1 to 17, they were positive, and from 17 to infinity. So it was like this. 1 to 17, they were all here. After it had 17, it was all here to infinity. Okay? All right, and then the next function is cubed function. So pause that if you need to write it. Now, cubed function, remember that we're going to write f of x equals, and a cubed function is going to be under functions right here. Okay, and our function was -2 in the front, so that's a 3. It was -2, cube function x plus 1. Now remember the cube function continues to go, okay, forever and ever. So that means that this is going to be all real numbers or negative infinity to positive infinity. And this is going to be all real numbers, negative infinity to positive infinity as well, okay, because it's going to continue to go. Now again, how do I determine positive and negative numbers is when they transition. So right here at -1, which is your x-intercept, this is where, right here, this is at -1 when it transitions. So these are all negative because they're below x-axis. These are all positive because they are above x-axis, okay? So how do I write that? Negative infinity to this number, they all positive. After this number, -1 to infinity, they all negative, okay? So again, negative infinity to -1, they positive, and after they hit -1 to infinity, they negative, okay? All right, and the last two questions on this graph right here, they're open. Again, I'm going to graph it. So this one, let me take that back. I can just change it. So this one is negative 2x minus 1. And then on the outside, you have minus 2. So first, it's asking you for no, it doesn't ask you for transformation. Never mind. All right, so first it's asking for domain and range. So remember, cubed function has domain and range, all real numbers, negative infinity to positive infinity, either or. It's not, you don't have to write both. It's just continuously to go, okay? Now, increase, decrease, we're gonna look at a function. And again, the way that I do it is I start with the very far left, okay? I start right here, and I'm gonna follow the function with my finger. It is going down. So that means it's decreasing, and it can only do one or the other. So this function is not increasing, it is decreasing infinity to infinity, because again, it doesn't have a stopping point, okay? Questions that are positive and negative. So again, we are going to look for the x-intercept. That's at 0. So that means we are going to look at what is above x-axis. This is your x-axis. So as you notice right here, these are all positive. These are all negative, okay? So negative infinity, you read it left to right, to 0. To that x-intercept, it's positive. After it hits that 0, to infinity, not down, to the right. We're reading it left to right. It is negative, okay? So negative infinity to 0, and then at 0 to infinity continues to be negative, okay? Now right and left behavior, again, what we want to do is we want to find ourselves the flat area right here, all right? The middle area right here. If I'm going to the right, which is always positive infinity, if I'm traveling to the right, straight to the right, I need to go down to meet that line of that function. So that's negative infinity, okay? So if I'm traveling to the right, I am going down. So going back here, if I'm going to the right, which is positive, I'm going down, okay? Now on the other hand, once again, find that middle, flat area right here. Now I'm going to the left. I'm going to the left, and what's the left? Negative infinity. Now for me to reach my function, to touch that function, I gotta go up. Up means positive, so negative, positive. Negative, positive, okay? All right, now pause that if you need to. All right, question 26, very quick right here. For question 26, we're going to change the function. So we're going to have f of x equals, now we have a square root of function, x plus 1 plus 2. All right. So let's press home so it looks better. All right. So again, this function has a stopping point. The stopping point is -1 and 2. All right. So this is -1 and 2. All right. So again, what does that mean for me? That means x is -1. So domain, I'm going from -1 to the right. So -1 to infinity. Or all the x's that are greater or equal to -1, okay? Range is going from 2 up, okay? So from 2 this way, all right? So again, that's 2 to infinity, close parentheses, 2 to infinity, or all the y's that are more than 2, because it's all the numbers that are more than 2, 4, 6, 7, 8, 9, 10, okay? So again, -1 represents x, you're going to the right, and then you're going up from 2, okay? So here we are going to say -1 to infinity, close parentheses, 2 to positive infinity as well, or all the x's that are greater or equal to -1, and all the y's that are greater or equal to 2, okay? Now increase, decrease, this function only will have 1. This function, again, if I am putting myself right here at the starting point, and I follow it, I am going to go up. Okay? So I am going up from -1 value. So from this value right here, that's the same value of that point, which was -1, 2. Okay? So I am going from -1 to the right. This is where my function is increasing in that area. Okay? So -1 to the right, which is positive infinity, is when my function is increasing. No decrease. So -1 to infinity. So I want you to see how these repeat. Okay? Positive and negative. Let's look at the function again. All of the functions above x-axis. So if I'm looking right here, this is my x-axis. Okay? The whole entire function is right here. It's all positive. Okay? All right. So that means, again, how am I going to measure that? From that -1, which is that point over where it starts for x-axis. So -1 to infinity, again, I'm going to the right side, -1 to infinity, it's where the function is positive. I'm showing the area. So -1 to infinity. I want you to notice that it will repeat. There is no negatives, okay? Now left and right behavior, okay. So this one might be just a little bit trickier. So here is my point, okay? This is my right side. So if I'm going to the right, I'm always going to pick the one that has the arrow, okay, the continuous. So if I'm going to the right, I'm going toward positive infinity. After I go to positive infinity, to meet my function, I also got to go up. So the right side goes up and up, positive and positive. Now, on the other hand, the left side must stop at the point. Remember, the left side then cannot have infinities. And so this point right here, again, is at -1, 2. So that means when my x is going toward -1, which is my x value, my y value is going to 2. Okay? So what does that mean for me? You're going to use this as your point. Again, the point was -1, 2. So -1, 2. As my x is going to the x value, my y is going to the y value. Okay?